Chapter 6, guys, we're going to talk about exponential functions. And an exponential function, you're going to have a variable in the exponent. Everybody know where the exponent is? Up in the top corner. Today we're going to talk about growth and decay, all right? We're not going to graph these right now, but you guys need to understand what the graph looks like. An exponential function, it says it up here, has the form y equals ab to the x, okay? Your exponent is going to be a variable. That's what makes it an exponential function. B is your base. B is the base, and it says right there that the base will not be 0. You cannot have a base of 0. It could be any other number, but it cannot be 0. You have two kinds of exponential functions. You have a growth or you have a decay. What do you think the growth does? Does it get bigger or smaller? Bigger, right? Your exponential growth is going to get bigger, so your exponential decay is going to do what? Get smaller, okay? So we're going to talk about the growth factor itself. And it's the number in parentheses. And you're going to talk about if it's a growth or a decay. If it's bigger than 1, it's a growth. If it's in between 0 and 1, it's a decay. So think about it in comparisons to 1. So if I look at an exponential function graph, okay, it does not look like a line because it's not a smooth, constant slope kind of thing. If you notice, an exponential function usually starts off kind of slow and then it gets big in a hurry. Because when things grow exponentially, they get bigger, faster. Same thing with a decay. Think about if you have 2 to the first power is 2. 2 to the second power is 4, right? Then 2 to the third power is 8. Then 2 to the fourth power is 16. The numbers start to get bigger a lot quicker when you have an exponential function because it's not the same as just multiplying by 2. Does that make sense? You guys understand that? All right, all of your exponential growth and decays will have something called an asymptote. Does anybody know what an asymptote is? It's like a boundary line that your graph gets really, really, really close to, but doesn't touch. All right, it's going to get really, really close to, it doesn't touch. Sometimes your graph will move up and down the y-axis, might move left and right to the x-axis. Those are transformations, and your asymptote will change. But for right now, when we're looking at this graph, your exponential growth gets really close here to the x-axis, but never, ever, ever touches it. It's going to continue to use every x value from the left to the right, but it's never going to go below where x is 0. Everybody see what I'm talking about there? Does that make sense? You're always going to have an intercept where it's going to cross the y-axis. How would you find the y-intercept? You plug in 0 for x. Figure out where that is. All right, so your decay is the exact same thing, but just in the reverse order. Instead of going upwards like this, which way is your decay going? Which way does the decay go? It goes down. When we read a graph from left to right, your decay gets smaller. This is where this growth factor, and we'll show some examples here in a minute, but where the growth factor, whatever your B term is between 0 and 1. It could be a fraction, it could be a decimal, but it's in between 0 and the whole number 1. That's what's going to make it a decay. You guys have talked about transformations before, right? Like if there's a negative in front of a function, like if you have negative x squared, then that's a reflection. You guys talked about that, right? Transformations. Okay, so if you have like negative 3 to the x power, that does not make that 3 negative. That's just saying that there is a reflection occurring. Your growth factor is right here. Is this number bigger than 1, or is it in between 0 and 1? The whole number 3, is it bigger than 1 or is it in between 0 and 1? It's bigger, so that would be an exponential growth. If you had something like negative 1/2 to the x power, look at your growth factor. That negative just makes it reflect over the x-axis. That does not have any effect on whether it's a growth or a decay. Your growth factor here is 1/2. So is that bigger than 1 or is that in between 0 and 1? It's in between 0 and 1, so that would be a decay. So that's what we're going to do now. We're just going to kind of look at these different functions, and we're going to just say, hey, is this an exponential growth or is this an exponential decay? So what I want you to do is identify the base. Sometimes there's numbers in front of it, sometimes there's numbers behind it, but whatever is attached to the exponent is your base. So is this number greater than 1 or in between 0 and 1? It's greater than 1. So since this is greater than 1, this is an exponential growth or decay? It's a growth. Good. Now, if you guys were to graph this, how would you do that? Well, you just plug in values for x. -1, -0, 1, 2, and then you can plot your points, and you would see that it grows, a nice smooth curve. So I look over here and I say, okay, here is my growth factor. It's what's attached with the exponent. Is this number here in between 0 and 1, or is it greater than 1? It's in between 0 and 1. So if it's in between 0 and 1, is this a growth or is this a decay? Very good. It's an exponential decay. Good. Everybody okay? All right, let's look at some more. All right, circle your base for all of them. Circle your base. Circle your base. Sometimes it's by itself, sometimes it's got other stuff hanging out. Circle your base. Number 1, exponential growth or decay? Perfect, exponential growth. Number 2, growth or decay? Why? Good. Just because it's a fraction, should we just automatically assume it's between 0 and 1? No. Okay, good. What about 0.25? What's that? A what? Decay, good. What about 1.5? Good. So good, guys. Don't get fooled. If you have something like 3 over 2, a lot of people are like, oh, it's a fraction. What's 3 over 2? It's 1 and 1/2. It's bigger than 1, right? So this would be an exponential growth. Just be careful. Don't get fooled by something silly like that. All right, everybody all right so far? Okay, these are exponential growth and decay models. COVID is a really good representation or example of an exponential function. Started out with just a few cases, right? And then as it spread, it exponentially got bigger. It's not great. But in an exponential growth model, or an exponential decay model, what is the only difference you guys see? Look at those two, look at the two formulas. It's the only difference you see. The sign. In a growth, what sign is there? A plus sign, addition, good. In a decay, what sign do you see? A subtraction, okay? So it says right here, some real-life quantities increase or decrease by a fixed percent each year. A fixed percent. So you guys are going to determine the growth and decay factor, which is right here in the middle. If the number is less than 1, it's a decay factor, correct? If you have 0.5, something like that. If it's more than 1, then it's a what? Bigger than 1 gives us a what, guys? A growth. Less than 1 gives us a what? A decay. So you're going to figure out if something is a growth or a decay, and you can tell by that in real life stuff if the number is bigger than 1 or less than 1. So this is what they're talking about here. The value of a car in thousands of dollars could be approximated by the model, blah, 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 where T is the number of years since the car was new. All right, the first question says, tell whether the model represents exponential growth or decay. Where do I look? What matters when I look at this equation? Where is the growth or decay factor? It's right here. It's attached to the T, right? So I look at letter A and I say, okay, is this a growth or a decay? It's a decay. How do you know this is an exponential decay? Correct. Because 0.85 is in between what two numbers? Very good. In between 0 and 1. Does that make sense? Now it says to identify the annual percent increase or decrease in the value of the car. Well, how do we figure that out? If you go back to the last slide, the growth factor is either, God bless you, 1 minus R or 1 plus R, right? This is a decay, and this is a growth. You guys agree? So which one would I be looking at, the 1 minus or the 1 plus? 1 minus, okay, good. So I'm going to say, well, what does, if I look at B, I'm trying to find out what the percentage of the rate was. Which formula am I using, 1 plus or 1 minus? 1 minus, so it's 1 minus something gives us what number? The 0.85. You guys see that? You're going to set whatever the growth factor is to whatever is inside the parentheses. So how would you solve this? You want to get R by itself. I have 1 minus R equals 0.85. What would I do? What am I going to do? I'm going to subtract 1 from both sides. Minus 1. Okay, so I have negative R equals. Guys, think about money. This is 0.85 minus 1.00. Right? $1 minus 85 cents. Agreed? Negative $1 plus 85 cents. However you want to look at it. What's the difference between 0.85 and 1 whole? 15, right? So negative R equals negative 0.15. So what does R equal? R equals 0.15. Is that a percent? Yes or no? No. How could I make it a percent? I could multiply it by how much? 100% or 100. So my rate of decrease is 15%. When you're finding the increase or decrease rate, you first identify if it's a growth or a decay, 1 plus or 1 minus, and then you just set whatever's in the parenthesis equal to that and solve. Every time. It's either going to be plus 1 or minus 1. Every time. You just have to identify which it is first, a growth or a decay. I think we got one. All right. In 2000, the world population was a lot. During the next 13 years, the world population increased by about what? It increased by what? 1.18%. So let's talk about this for a second. Is this a growth or a decay? It's a growth. How do you know it's a growth? Because it's greater than 1, right? How much did it grow? %. If you guys, some of you are like, oh, I don't know. Well, think about it. What's your growth factor? Is it 1 plus R or 1 minus R? So I'm going to say 1 plus R equals 1.18, correct? How do I get R by itself? Subtract 1. So R equals 0.18. How do I write 0.18 as a percent? 18%. So this question says, write the exponential growth model and building to estimate the world population. All right, we need a calculator for that. We'll start that tomorrow. We'll finish, what is it, 3 more? And then look at your homework. See if you guys have any questions on homework.